In this video we're going to take a look at 3 different word problems, each with 2 different categories. Here we have 2 different trains. On this next one we'll be traveling on a level road and a winding road, and then finally we'll be wondering how many $10 bills, how many $20 bills showed up. And I'm going to try to solve these in much the same manner as the previous ones, where we use this chart. It's going to be slightly different though. We set up our categories and then we have our variables, but in the previous mixture problems we combined 2 things to get a third, and that's really not what we're up to here. So let's go ahead and get started, and maybe that difference will become apparent after you've worked some of these problems. Okay, for our very first one, as you can see from reading this, that we're comparing 2 different trains, and they're talking about distances, rates, and times. That might not jump out for you, but once you've been working with mathematical or physics problems much, you encounter this formula: distance is equal to rate times time, a lot. So you just get used to sort of looking for it. Okay, so we're going to have this in mind as we work on this problem. To get things started, we need our categories. Okay, so we've got a freight train, so let's say that's our FT, and it's going at 40. It's miles per hour. I'm just going to put 40. And then the other one we have is a passenger train. The passenger train is going 80. Alright, so here's our passenger train, and I'm just going to write 80. And again, just like on the other charts, I'm just trying to establish my categories so I can get something on the paper and start thinking about this. Alright, so here's our categories. And let's see, in the next compartment I'd like to get my variables in here. So let's see. "4 hours later, parallel track." So they're comparing these 2 trains in terms of time. So this train, we'll just say it leaves at, well, we'll figure it out, but I want a T, I want time in each of these categories, but they're not the same, right? One of them left 4 hours later. 4 hours later. So the passenger train left 4 hours later. I think it'll be a good idea to subtract 4 from T for the passenger train. Alright, before we go any further, just make sure that makes sense. Let's say the freight train has been traveling for 10 hours. If the passenger train left 4 hours later, it would be traveling for 6 hours. Okay? So we just did that to try to get our variables on the paper. And what are we going to call this category? Seems to be time, right? Alright. And then I'm really thinking about this. Distance is equal to rate times time, and they tell us 40 miles per hour and 80 miles per hour. So let's call this our rate. And this one's 40. This one's 80. I guess I can say miles per hour just for emphasis. And what else do we have? Distance is equal to rate times time. Okay, so over here I'll say distance But I really don't know the distance yet. In fact, that's what I'm trying to find out, is the distance. So, but I can represent it as rate times time. Rate times time. So I'll just write this as 40t, and then for this train, the passenger train, I'll write it as 80t minus 4, or the difference of t and 4. Or probably the best way to say it's the quantity, t minus 4. Alright, and now what we're going to do, you remember on these other charts, I'll pull them in here for a second. On these we had a third category, and we kind of worked with these two and set them equal to the third category. That's not quite what we have going on here. I don't know the distance that the freight train travels, and I don't know the distance that the passenger train travels, but I know that when they meet, they will have traveled the same distance. It will have taken a different amount of time, but once they meet, obviously they've gone the same distance. That's an important concept here. That means that this distance is the same as this distance. So I have an equivalency. I can write my algebraic equation. So I could say, maybe I'll put that in black. It basically, this is equal to that. Alright? So 40t, oops, running out my paper here. Just like that. So 40t is equal to 80 times the quantity t minus 4. All we have to do is solve for t, and we'll know the time involved. Okay? So we will have to distribute our 80. Four times 8 is 32, and just tack on that 0. Just bring down our 40t, and let's get rid of our 80t here. And take a look at what we have. So this is a negative 40t. Oops, off my paper again. I think I'm going to zoom. Well, I'll just slide. I'll zoom out one. I don't know. I'm getting so much of my desk in here. We'll just go like that. That's a 0. And we have negative 320. Might be a little bit disconcerting to see negative time, because we can't have such a thing as negative time. Well, but that'll work itself out, so I'm not too concerned. We want t by itself, so let's get rid of a negative 40t. It's held by multiplication, thus we divide. And the left side cleans up very quickly. Negative divided by negative is positive 1. And divide by 10, divide by 10. 4 goes into 32 8 times. Again, the signs become positive. So we found out that it's taken, or that the time is 8 hours. Now I do have to zoom out. Alright, so let's see our time is 8 hours, and what they want to know, how long will it take the passenger train to overtake the freight train? If we plug in this 8 right here, it says that it'll take 4 hours. But that's not really the question. How far from the station will they meet? Alright. So, well, I think I'll use a different color so it stands out. Green. Alright, so how far from the station will they meet? We take our 8 and we plug it in there. 4 times 8 is 32. Tack on a 0. And out comes 320 miles. Okay. I could have plugged it in here just as well. If I plug an 8 right in where the T is, 8 minus 4 is 4. 4 times 8 is 32. Tack on a 0. Out comes 320 miles. We'll take a look at the next one now. Okay, we have a bus traveling on 2 different roads. So we're still going to be thinking about, we have rate and time, distance, so I still want this formula D equals RT to wander through your head and onto the paper. And let's try to get some categories going. We've got a level road, and we also have, there's our level road. Notice that was 6 hours. I'll put 6 hour. And we have a winding road. I'm just going to put RD for road. And that was 3 hours worth of driving. Alright, so we have our categories. And we want to get some variables in here. So let's see. The speed or the rate is 20 miles per hour faster on the level road. So for the rate, we're trying to find the rate. So they're saying find the average speed. We'll call that the rate. And how do we do this? I'm just going to use X or R. I'll just use X for the rate. Alright, and again, they're compared to each other, but they're not the same, right? We're going faster on the level road than the winding road. So it said the level road was 20 miles per hour faster. Okay, that gives us our, again, we're just trying to get stuff on the chart so we can handle it and figure out what to do with this stuff. Okay, rate times time, so our time is 6 hours, and here the time is 3 hours. And let's see. So again, I don't know the actual distance. Oh, let me see. Level road. The entire trip was 462. But I can't say that on the level road it was 462. I can't say on the winding road it was 462. The combination of these two is 462. So for distance, I'm going to need to describe it as rate times time. Alright? So the rate is x plus 20 and the time is 6. And usually we would write that as 6 times the quantity x plus 20. And this would be 3 times x. Okay? And here's where you have to see that whatever this distance is, this is a distance. Might not look like a distance, but this represents a distance. If I add it to this distance, if I add these two, I'm going to get 462 miles. So I'm going to have to, there we go. So if I add them, I get 462. So we have 6 times that quantity plus that quantity, 3x. That's equal to 462 miles. Okay. Now we're going to solve for x. And of course, got to get this guy out of parentheses. Distribute your 6. 120. Okay. Bring down everything else. Combine like terms. Get rid of that 120. Try zooming out one here. So we have 9x is equal to 342. That looks pretty good. Get rid of your 9. Goes into 9 once, so we figured out that x is equal to I'll just do this on paper. I want to be careful. I don't like making mistakes on video. Okay, so 9 goes into 34 3 times. And 9 goes to 72 8 times. So there's 38. So this is what x is, but what did they ask? Okay, so x equals 38. I'm going to bring that information up a little bit, and I'll write it again. X equals 38. Find the average speed on the level road. Okay. on the level road, we have to plug in our 38 right where the X is, and out comes 58 miles per hour. So that's our rate on the level road, 58 miles per hour. Okay, we'll take a look at how many $10 bills and $20 bills showed up in the till. Hopefully you're starting to see the categories form. Sorry about the little bugs here, go away bugs. Alright, so we have, I don't know how to say it, I'll just say $10 bills and $20 bills. Alright, and again, this is just to organize the categories. We're not really going to do anything here. These are the categories. And I'd like to get some variables in here. They want to know how many. So I'll put, this is the number of bills, and I want to use the same variable, so I'm going to say X and X. There's 3 more 10s, so 3 more $10 bills. That means I have 3 more. Okay, so we have our variables in there, and this is the denominations. Couldn't they find a longer word for that? Alright, so these are the 10s, and these are the 20s. Let's see. I'm going to call this value. And I have $10 worth of X plus 3 bills. So that's 10 times the quantity X plus 3. And I have X number of $20 bills, so that's 20X. I want to be sure I said that right. I have X plus 3 number of $10 bills. That's X plus 3 $10 bills. And I have X $20 bills. X $20 bills. And again, if I add these to these, the value, the amount of money is $340, right? So, I'm sorry, $390, $390. Zoom out a little. So again, if I add this to this, I should get 390. So that's 10 times the quantity X plus 3 plus 20X. And I'm going to go ahead and solve for X. We'll send our 10 into each term. Bring down whatever we haven't touched. And let's combine our like terms here. So we have 30x and then plus 30 equals 390. Get rid of that 30. Slide up a little more. So we have 30x is equal to 360. Get rid of that 30. Goes into itself once, so x is equal, divide by 10, divide by 10. 3 goes into 36 12 times. So I have x equals 12, but I might not be finished yet. What do they want to know? The number of each denomination. Okay, so if x is 12, if I have x equals 12, let me zoom out one more here. And then I need to plug in a 12 wherever there's an x, and out comes a 15. So I have 15 $10 bills. Plug in a 12, and big surprise, out comes 12. I have 12 $20 bills, and we can kind of check that real quick. 15 $10 bills, that's $150. 12 20s, 10 of them would be 200, and then 2 more would be 40, so that's 240. So there's our 390, all accounted for.